Hey everybody and welcome back to Jim's Garage. In this video we're going to be deploying Kubernetes using Ansible, specifically RKE2, not K3s. I'll come on to that in a minute. Also, I want to say a big thank you to everyone who supported me. I've been doing YouTube now for basically a year, so this is pretty much my anniversary video, and what better way than to nerd out with Kubernetes. Thanks again for everyone who supported, liked, subscribed, all the comments and feedback I've had over the past year. I've learned a ton and it's been great getting to know you. Anyway, let's get back on course. So as I said, this script is going to be deploying RKE2. What is RKE2? Let's have a quick reminder for those who might not have seen my RKE2 script video. RKE2 is basically K3s's bigger brother, designed specifically with security in mind, meeting the FIPS 140-2 and also getting a clean bill of health from a CIS benchmark. Also, I didn't want to compete with Techno Tim. He's got an awesome K3s Ansible playbook that you should definitely check out. It has more features than the one I'm going to show you today, and it also has a ton more support. Hopefully I can get there with RKE2, but I'm going to need your support. So please feel free to submit PRs, etc. I'll show you some of the suggestions that I think would make this a lot better as we get into the video. Anyway, hopefully this is going to provide you with the easiest way to get RKE2 set up, and now you've got no excuses for spinning up Kubernetes on your infrastructure. Let's dive into VS Code, let's get going. A warning, you're going to need a drink for this one. It's going to take a while, but it's going to be worth it. So, with the brew in hand, it's an Assam by the way. Let's get on to looking at some of the prerequisites. If you're looking at this screen now, you'll have noticed this before. I've got RKE2, 01, 02, 03, 04, and 05. This is going to set up a 5-node Kubernetes cluster with 3 servers and 2 worker nodes. Now, RKE2 is a little bit heavier than K3s, but nothing too significant. You can see here on the screen, I've got 20 gigs of space, I've got 4 gigs of RAM, and 4 cores. Now, that's enough just to get this started. As you put more workloads onto this, you're going to need to scale that. Certainly the workers, because those are the ones that are going to be hosting most of the content. Now, I've only tested this on Ubuntu 23.04, but it should work on pretty much all Debian-based distributions. But I do want to get onto all distributions and all architectures, not just your AMD 64s, but also ARM architecture, but I'm going to need your help to get there. So hopping over onto VS Code, let's begin the process. So as you remember with all of my videos, I've got them on the left here, and this one is conveniently called RKE2. Having a look in the RKE2 folder, we've got some collections, inventories, and roles. The inventory and roles we've seen in the previous video, albeit this one's going to be calling many more FQCNs because there's some funky stuff going on in this playbook. Not all of that is probably the best way to do it. Again, this is how I've got it set up, and I really want you guys to help and contribute to improve it. And we've also got some collections. Now, the collections are basically the requirements for this script to work. And if we click on those, you can see that we need Ansible utils, the community general, Ansible POSIX, and Kubernetes core. These are basically bolt-ons to Ansible that enable you to call different FQCNs and have different functionality. So the more collections you add, the more Ansible can do, albeit some of those don't always get maintained for a long period of time. So if we have a look in the inventory, that hasn't really changed since the last time. I've got the 5 machines here that you just saw in Proxmox. I've got 21 to 23 set up as servers. That's the new name for masternodes. And the agents, which is the new name for workers. If we look in the group variables, I've tried to put everything in here that you need to change. So let's have a quick look through here. Now, these are actually defunct and not required at the moment, but might give you a little bit of a hint as to what I'm working on. So as with this script, it's not going to stay static. This video should still be useful about talking about the core components, but don't expect the script to look like this over time. I do want to improve it. Now in here we can specify the kubevip version. That's because we're using kubevip for that virtual IP. We specify the Ethernet interface that's on your virtual or physical machines. We specify what the VIP is, that virtual IP. So this in my case is on the subnet of 3 and is IP50. So this needs to be something that's unique and not used by anything else on your network. The beauty of the VIP is that you'll be able to ping and call this IP address here, and it doesn't really matter which node responds to it. Basically, all of the nodes are going to share this IP address. That gives you high availability, and that's one of the benefits of Kubernetes. Next, we're going to be using Metal LB. That's the Metal Load Balancer. That's because natively cloud would provide this for you, but because we're not cloud, we need to do this ourselves. Now the LB range again is just 3.80 to 3.90. That's giving me 10 IPs that I can expose my services on. You can obviously choose whatever range you want, however big you want that range to be. It's completely up to you. Just make sure again that there's nothing conflicting on your network within that range. I also give it a name for that pool, so I've just called it the first pool. You can create multiple pools if you want to. Then we get on to specifying the version of RKE2 that you want to run. I'm running this on 1.29.4, which is just the latest version. However, do make sure that if you want to run things like Rancher, that's not included in this playbook, but I've obviously covered it extensively before, and you can still follow that process once you've run this Ansible script. I just want to keep this bare bones just down to RKE2 so that people can use this and then spin up whatever they want on top of it. Do bear in mind that Rancher currently doesn't support 1.29.4 officially. I've been running it on mine and it seems okay, but again, I don't recommend running stuff that isn't supported. I think you can drop down to version 1.28, that's the latest supported version. Then it has an RKE2 install directory, so this is where it downloads the RKE2 binary. And it's also got the RKE2 binary URL. That just then uses a variable like we've done before, this one here, and just sticks the version we want into the URL so that it pulls down the right binary to deploy it. Next, we've seen this before, the Ansible user. So this is basically the local account on all of your virtual or physical machines. If you followed my cloud init videos, you'll know that I set up all of my users as Ubuntu. So change this to whatever user you want to use. We need to become true. That's because most of the stuff we're going to be doing requires the root privileges, so things like installing stuff, stopping services, etc. And we also want to do that by becoming sudo, which is the natural way of escalating privilege on Ubuntu and Debian systems. So with that out the way, we're ready to get on to the playbook. I'll stop and take a drink. So what we need to do is go into the roles. And you remember in my previous video, we did quite a few roles. This time, we've got a load more. Now, before I go into those, don't just look at them in alphabetical order. Let's have a look at the site.yaml. This is new. So I've tried to put in as much text here to help you guys out. If you're not going to watch this video, I don't blame you, it's going to be long. I've also put at the top here some of the things that I think would be useful to improve this. So I'm going to call out some of the shortcomings. It does work, I promise you, but these are things that I would like to be improved, and you can help with that. So I've already mentioned different OSs and architectures. Supporting multiple CNIs, so this version here, as is now, this will change in the future, fingers crossed, is just going to install the default of Flannel. Now, it would be great to have things like Cilium, and we can add that in the future, and hopefully, again, that will just be a case of modifying a variable, and then it will go and deploy Cilium. I need to improve some of the wait logic on here. At the moment, it's a little bit hacky, we'll get into that in a minute, but it does work, but there's probably better ways to doing it. That's both my lack of knowledge of Ansible in great detail and also my lack of knowledge of some of the more complex Kubernetes things. There's probably better ways of doing what I'm doing in this script. That kind of ties in with the next point where there are probably better plugins to use than I'm using. There's probably a better logic to how I'm doing this as well. There probably are too many steps in what I'm doing and just a general cleanup and polish of the whole thing. Anyway, enough beating me. Let's carry on. So what does this do in the site? So basically you change all of your variables like we've already covered, And this covers out essentially how this playbook is going to take place. So you'll see here, the first thing we do is to prepare all the nodes. We specify both servers and agents. That's because we need to do work on the servers and the agents before we can join it to a cluster. We then download RKE2. Again, we specify the servers and the agents because that binary is going to have to be downloaded to all of the servers. Each one of these will call a role, and that's basically what's in this folder here. The key thing to understand here is this is in order. Next, we're going to deploy kubevip. We're going to do that just on the servers. That's because the kubectl commands only need to be run on the servers, not the agents, hence servers. Next, we want to prepare RKE2 on the servers and agents. So in this bit, I'm basically setting up all of the configuration files, making sure that it's set up properly with all of the variables that you've stated. Then we add the additional servers. So we effectively up here, we're bootstrapping that first master node. Sorry, server, I'm still getting used to it. You'll have noticed that when we went through the script in my earlier videos. Then we use things like, is typically the token that we need from bootstrapping the first. That allows us to join other master nodes to this. Then we add the agents to it, and the agents will require that token to join. And then we add the manifests. So these are the remaining configuration files for kubevip and metal-lb. So let's go through this now in order and let's understand what's going on here. So the first thing is to prepare the nodes. So looking at prepare nodes, we go to here and we click on this one here. So all this is doing is enabling IPv4 and IPv6 forwarding, and that's needed for some of the communication between the nodes and some of the more advanced networking. This will probably get used more and expanded more once we get onto different CNIs. After that, if we have a look, we go to download RKE2. So download RKE2 calls RKE2 download. Again, you see the cleanup. I should probably keep these names consistent. We click on that, and then this time we've got a couple of folders. The key thing really is the tasks here. So there's 3 tasks in here. The first one, we've seen this before in earlier videos, is to actually make the directory for downloading the binary. This takes in the variable that we specified earlier for where we want that install. Then it's going to download the binary and it's going to put it in the directory we've just created. And then it's going to set the right permissions so that we can execute that in the next step. So going back to the site, we've done the RKE2 download. We're off to kubevip. So having a look in kubevip, we've got a couple of things. We've got tasks and we've got templates. And you'll remember templates from the last video where we looked at Docker Compose files. That's pretty much the same thing here, except we've got a configuration file for kubevip. Now, I'm not going to go into too much detail on this, but you can see that it's collecting some of the variables we specified. So effectively, this is a configuration file for how kubevip gets deployed. It takes in dynamic variables that you specify. Key things really are that VIP interface, so in my case that eth0, and I think further down, yeah, it takes that virtual IP address here. So this sets up kubevip on the Ethernet 0 and gives it the IP address of 3.50. If we look in the task though, we can see that we need to create a directory for that kubevip manifest. That's that thing just down here. And then we need to copy it over. So the handy thing is with K3s and RKE2 is you can actually deploy some of these configs into this manifest folder before you start up the server itself, and on that first boot it's going to apply this stuff, which is quite handy. Don't want to get too into the weeds on this one, but it means that you don't have to run things like kubectl commands. It's actually going to do that for you off the bat. And actually I'm also thinking about later on in this script, I'll show you where I do deploy things with kubectl. It might be better to actually put some of this stuff in the manifests folder. The problem sometimes though is you get into a race condition whereby certain things have to have happened before the next thing can happen, and if you get out of sync, bad things can happen, i.e. it just won't deploy. So let's go back to the site. And after we've done kubevip, we get onto the RKE2 prepare. So this is preparing the servers and agents before we start booting things up. So if we go into RKE2 prepare, you'll see that we've got tasks, templates, and variables. We'll have a look at the variables first, but this is basically a placeholder for an empty variables folder that I'll probably fill out with some improvements later on. The templates again, so this time we've got 3. You'll actually notice later on that there are 4, but we just don't deploy it at the moment. So the first thing we're going to look at is the server configuration. So you'll remember from my previous video with the script, this is basically setting up the configuration of that first bootstrapped server. So what this is saying is give the kubeconfig file 644, which is the permissions it expects, otherwise it's going to start complaining. It sets the TLS SAN, so this is basically the IP addresses that are bound to it and will respond to it, to the VIP, and then also all the IP addresses, so these are referencing host variables for server 1, server 2, and server 3. So basically it's saying that all of these can be reached and do things. They're all basically the servers. It's going to give them a node label of server true. I've created that. You can put whatever you want in here. And I've disabled the ingress of Nginx because we're going to be using MetalLB and we'll use traffic as well in the future, or I certainly will. You can delete this to re-enable Nginx if you want to use it. After that, we've actually got the services. So these are service files for basically Linux, in this case Debian, which basically we copy to the remote machines and then we enable this service. That means that it starts up and then each time you reboot the machine, RKE2 will be running. I also do the same thing for the agents and that looks exactly the same. Just note the agent and not the server. There is some logic to which order these get set up first. Like I said, we first need to run that server 1 and bootstrap it. We then need to get all of the details it auto-generates on first boot, and then we copy that to the other 2 servers. Then once we've done that, we can then add the agents afterwards. So looking in the tasks for this one, there's quite a bit going on. The first thing is to create a directory for that configuration file. The next thing is to create a directory for the token. Now, if you remember what I've just said, the token is kind of the secret key that is created on that first spin up of the first server, and we need to copy this to the remaining master nodes and servers and agents for them to join. So the first thing we're going to do here is deploy the server configuration. That's this file down here, and we're going to put it in the RKE2 config.yaml. That's where it expects it to be on that first boot. Also, I'm making a lot of uses of the when clauses in this, and again, there might be a better way of doing this, but basically what I'm saying is go and copy this config file over to all of the servers. So it's going to go to each one and copy this over. That's because for that one, the TLS SAN is going to be the same for each one. I'm then copying over the service files. So these are the server service files. Again, that group of servers. Then we're creating the service file for the agents, doing exactly the same thing, just copying this agent one this time, and you can see agent specified here. Now we get on to the important bit. We enable the first server. So we're going to make sure that it's running and it's restarted and it's true. And I'm critically only doing this for the servers group, and if anyone knows arrays, this is the first item in that servers group, i.e. server 1. What we're doing is we're waiting then for this to start up. It's not instantaneous, and again, this is where I'm talking about those race conditions. We have a wait built in, and you'll see the FQCN of wait for. And what this is doing is waiting for this node token to become available. It's only doing it for that first server again. There's no point in connecting to the others because we're only spinning this one up. We're then going to wait for kubectl. Now, technically, well, when RKE2 spins up, it automatically downloads the kubectl binary. And kubectl is kind of kube control. It's a command line interface tool for managing your cluster, deploying things, querying things, all those sorts of things. And we'll call it later on. So we need to wait for that to download. Now, because my internet is crap, some improvements coming on that, thankfully, videos soon. I've had to put in quite a few wait conditions, but these should be pretty quick if you've got fast internet. Next, we copy the kubectl to the user binary so that all users can basically use it. It maps it to kind of like a global home directory. We could probably put a symlink here and just reference the existing one rather than copying it, but I was having some issues with that, so I took the nuclear approach and I've copied this to the local bin. So basically this means now our home user, that Ubuntu, can use it without being a privileged user, which is pretty cool. And you can see that by setting 755 for the permissions. Next, I've got a wait command again because I want to wait for the kubectl to be copied over first. Then we're going to modify the token access. So before we wait for the token to be generated, we're now modifying the access mode for that token so that we can then go and grab it. We then want to save the token as a variable, and we use a new one here called slurp, which is quite funny and reminds me to have a cup of tea. Then we take the source, so that token resides in this location here, and we register it. Now this is a name I've called, makes sense to call it RKE token. And basically that saves that token as a variable in memory within Ansible so that we can call it later on. So I then convert that token into a base 64. I then decode that token in base 64 and then we save that. Next, we want to revert the token file access, so basically change that access back to what it was previously. Next, I'm going to make sure that the .cube directory exists in the home users directory. What's that? Well, as I said before, that kubectl is the command line interface for integrating and managing your cluster. But what it requires is a configuration file. And that configuration file will have the secret to access your cluster. It's a different file to the token we just copied. This is the RKE2.yaml, which we'll see below. But we basically copy that into the home directory because we need to reference that to be used whenever we want to make kubectl commands. If you don't have that reference, you'll get that spam where it will come out and say connection refused against each of your nodes. Next, we change the IP from the local to the server 1 IP. So within this config file, this .cube config, by default it will say 127.0.0.1 for a local host. We obviously want to change that from that value to the IP address of the first host, because then we're going to copy that to the other machines, and then obviously they wouldn't want to reference themselves to join a cluster because that doesn't make sense. We put in the IP address of the first server because we want every other one to talk to that first one and join the cluster. Then after that, they can communicate via the VIP and the SAN so that we've got high availability between all of the nodes. So if we go back to our site, now that we've done the prepare, we get on to adding a server. So we've done all the prep work, now we can add the other two servers after we've bootstrapped the first one. So this one's add server, so if we go up to here, you'll notice it's red, we'll come on to that in a minute. That's just because I've exceeded one of the string lengths for something, and again, if somebody knows a better way of doing this, please feel free to submit a PR. Having a look in the template, we've got that last remaining server configuration, and here you can see it's a little bit different. Here we specify that token, and we can actually call that by saying host variables server1 token, which is the name we gave it. And we also want to change the server, so these two variables weren't in the server1 config file, and we're going to specify that host vars of the Ansible host, because the first time these separate two masters spin up, they need to talk to the first server, but they also need to have the token present to be able to do that because it's an encrypted communication. Everything else in there is the same. So now let's go through what are the tasks for this one. So similarly to before, we deploy this configuration we just looked at onto that machine. Then we have another wait condition. So this one is one of those ones which was a little bit hacky, but what it's doing is basically waiting for the Kubernetes API to spin up. Now RKE2, like I mentioned, is a little bit heavier and a little bit slower in terms of first spinning up because there's more stuff going on. Actual performance wise, exactly the same with all the security benefits. But what I'm doing here is, and it could be dependent on your internet, again, mine's crap, and the hardware you're giving it, i.e. how many cores, RAM, disk drive, etc. But what it's doing is basically spamming this kubectl command to get the nodes, and it'll only get the nodes when it doesn't receive the connection refused. Now this is the error message that a lot of people got in my script because there wasn't enough wait logic built into it. And over time, if you did it, say 10 minutes later, you very likely get the output of the nodes. This basically stops everything happening. It will just print out this message here until it actually completes and gets the node, i.e. it will come up with server 1, and that means that then the API is up and running, which means then we can continue to add additional nodes and agents. So once it's waited for that to come out, and again, we're actually running that as the Ansible user not become, so we're not an escalated user here, we're just using this as the local user because we copied over the kubectl into the local binary folder. Next, we actually then use kubectl because the API is now available to us because we've waited for it. And we deploy some of the manifests that reside on the KubeVip website. So this is actually pulling out from the internet to go and get this. If we have a look, this is the role-based access controls for KubeVip are back here. After that, we apply the KubeVip configuration file. And again, this one is online. It does the same thing again. And you'll see that this is the KubeVip cloud provider, and it's actually the KubeVip cloud controller, which threw some people up on the script because it wasn't actually applying that, again because of lack of wait logic and those race conditions. Next, we check that the servers are restarted. We did this before. We need to do that because we need to make sure that it takes on board the new configuration files. We then enable the servers once it's restarted and once it's got those configuration files available to it. That should then join those new servers to the cluster because it has the config file, and crucially it has the IP address of server 1 and it has the token that allows it to connect, kind of like the secret password. So once we've done this one, the add server, let's have a look. We then get on to adding the agent, and this is the penultimate task. So if we have a look at the add agent, this one's pretty straightforward. We have a template for the agent configuration, and this one looks very similar, i.e. it still needs that token to do that first connection, and it still needs the IP address here to connect to the masternode 1, sorry, the server 1, and it doesn't have the TLS SAN. That's because it doesn't have that high availability context, i.e. it's not got all of the etcd and all of that sort of stuff running on it because this is a worker node, it's not a server. So we don't need that in here. So if we look at the tasks, hopefully this is getting familiar now. We deploy the agent configuration, so this file here, and then we basically spin up those agents. And they will use that configuration file, they will connect to the cluster, and they will be registered as agents or worker nodes. The last piece of the puzzle is to deploy the manifests. So if we just have a look in here, you can see apply manifests. If we have a look in the apply manifests, we'll have some templates. This is the Metal LB IP address pool, and this is a manifest file for Kubernetes that takes into consideration the variables, so the name and the range that we specified right at the start of the video. If we actually look at the tasks, pretty straightforward. We wait for the first server to be ready before continuing with Metal LB. So whilst before the kubectl API, sorry, the Kubernetes API was the first wait we were doing, This one I found was needed because I needed to make sure that the actual node was ready, not just the API was available. If I didn't have this in here, it started to get into that race condition where pods weren't available, so we couldn't actually apply some of the configurations. So again, this can take a while for those nodes to get ready, but just wait and it should complete. We then create a namespace, and if you remember from earlier videos, all the deployments should sit within their own namespace. So here we're applying the namespace for Metal LB just into the cluster. Again, we're just doing that on the first server. That's where we've copied kubectl, but you could add kubectl to any of your servers and run it that way. Then, because we've waited and the pods are up and running and all in the right order, we can then do the Metal LB version, and this one is the Metal LB native, which is one of the manifests required for Metal LB. Next, we have another wait because we can't apply any of the advertisements until we've waited for all the pods to be alive and available. So this is going to invoke a kubectl wait, and it's going to wait for all the pods within the Metal LB namespace to be ready. If I don't put this one in, and this one can take a little while, also do bear in mind that even if you've got wicked fast internet and crazy hardware, you can still be rate limited by things like the Docker hub, the Docker IO hub, because we're going to be pulling down hundreds of containers in this deployment. So do just be patient. I've put it for half an hour. In my experience, it takes about 5 minutes. But just do bear that in mind. If it's printing stuff out, usually it's working. Some of them aren't going to print out just because I didn't want to spam it too much, but just leave it, it should work. Once we've waited for that and it's completed, we can then deploy the next file, which is just the configuration file for the advertisement. So this is where it advertises, and that should just apply now that these pods are ready. Next, we then deploy the actual IP pool, so that's that configuration over here, and we do that by copying that over locally to the machine, and then we use a kubectl to actually apply that pool. And I can now take a breath, or at least have another sip of tea, and we're ready now to get into the deployment. So I'll show you this actually running in real time. And so to get this running, I'm going to cd to my RKE folder. And then hopefully it should just be a case of doing Ansible Playbook using the site. Remember, that's not the inventory's here. The site is that order of how it's going to do all those different roles. And I'm specifying the key file, which is my certificate, to join to these machines. So when I hit return, let's see what happens. So it's prepared all the nodes, it's gathering the facts so it knows all the software and conditions of it. It's created a directory for the download, and because my internet's terrible, it's now downloading that binary to all 5 of those machines. Maybe it would be quicker if I downloaded it to one and then copied it locally over the LAN, who knows. Hopefully not an issue for you guys with fast internet. Anyway, I'll skip ahead to once this is completed and then we'll continue the journey. So now that's completed, you can see it's set the permissions for it. It's now deploying the kube VIP. I'm probably going to have to scroll up a bit here. Yep, deployed the kube VIP here. It's created a directory for that manifest. You can see that the yellow indicates the servers where it had to do something. The green indicates where everything was already in the right position. And you can also see that sometimes I'm targeting 5 and sometimes targeting 3, and later on there's examples of 1. So we created the VIP manifest, we deployed the VIP configuration, we then move on to the preparing of the servers and agents. It then created the directory, created the token directory, deployed the server. Here you can see that it skipped the agents because all we're doing is deploying the servers, so it ignored those. We created the service file for just the servers. We created the service file for the agents. You see that's flipped over now, the colors. We ensured that the RKE2 is enabled and running, so just on that server 1 because we're bootstrapping the first one. We waited for the node token, so that's that token we need. That became available almost instantly. We waited for kubectl, that completed. We copied that to that home directory, that user bin, which is here. We then waited for that copy to finish. We registered the node token, so the token we saved earlier. We did that on all of them. We changed the file access for the node token on the first one back. We fetched the node token from the first server node. We saved it for later. We restored the file access. We ensured the kube directory exists in all of the homes. We then copied the config file to the home directory, replaced the IP address in that configuration file from the bootstrap for the first node. Now we can add the additional servers. So we deployed the server configuration to the other two servers. These are going to be those old master nodes. And here you can see we're actually waiting. So this is the first one again, I've said can take 5 to 10 minutes. Oh, it actually just did it there. So now the API is available and we can move on. Now the API is available, we can apply the kubevip configuration file. We can ensure the servers are enabled and up and running. We then get onto the additional RKE2 agents. So we're deploying the agent configuration now. We're ensuring those agents are up and running. And now we're getting onto the manifests. And I'll move my face out of the way. We now get onto the waiting for the K8s nodes label servers to be true. So we're waiting for the actual servers to be ready, so the cluster to be ready. Otherwise, we can't deploy manifest files. And this is the one where the rate limiting might be coming into effect. So this one could take a little bit of time. Now, in the background, I've loaded up my good old friend Putty. And if I do a kubectl get nodes, we should see the nodes popping up. So at the moment, we've only got that first node available, but to be honest, all we need to start this up and running is the first node to be actual ready. And this is the bit we're waiting for here. So here you'll see the node label needs to be true to be ready. You can see that it's not ready here. So that's what we're waiting for to change. And you can see it's been up for 2 minutes and 21 seconds, but in the background it'll be downloading a ton of pods before it's actually ready. Soon as this hits ready, it's going to go ahead then. It's got everything it needs to be able to spin up the remaining containers, or at least the metal LB and kubevip. So yep, there we go. So hopefully if I run this, yeah, you'll see that first one's ready. And now the two nodes have joined in the background. And now it's going to go away in the background here. You can see that it's applying the metal LB space, the metal LB manifest. Now it's waiting for the metal LB pods to come up. So hopefully if I remember this right, we can have a look at kubectl get pods -n. I think it's metal LB -system. Yeah, there we go. So those weren't ready. Now they are ready in the back, and you can see that everything then moved along. It applied the manifest, wait for the metal LB pods, applied the LB advertisement, the IP pool, and all of that. And as you can see, everything completed and everything's up and running. Now, at this point, I could put another wait in just at the end for you guys. This isn't up and running fully yet. It's going to take a little bit more time. You can see now that the controller's up and running. That's the bit that we were waiting for. Without the controller coming up, nothing's going to work. That's why we couldn't deploy these files. If we press up again, let's have a look at the nodes. You'll see that they're still not ready. So this is going to take some time. I'm going to go away and get another cup of tea, obviously. And when I come back, hopefully these are up and running. And you should see all 5 nodes, that's the 3 servers and the 2 agents, all saying ready. In my experience, it does take about 4 or 5 minutes. You remember that first wait. It's basically got to do that again for the agents. But do bear in mind now that, again, the more pods we're downloading, the more we're probably rate limited. What's interesting is you can actually see it's joined the 2 worker nodes, the 2 agents, to that server. And we're still waiting for the heavier server nodes to come up. That's because, again, that rate limiting, they probably need to have, well, they do need to have more pods on them, and that's obviously going to take longer with rate limiting. So now we've got the server and the 2 workers, and they're all ready. So in terms of a bare bones but not HA, because we don't have the other 2 servers yet, this cluster could actually start working. Now over time, here we go, you can see now that 3 is not ready, but it's joining. It's been in the cluster now for 7 seconds, and hopefully in a few seconds time the other one will be added. You'll notice that actually they're not doing it in order, which is interesting. No, it's not ready yet. I'll fast forward and I'll come back in a minute. So now we've got all 5 of them in the cluster, and we're just waiting for the secondary servers to become available. I'm going to save you the excitement of watching this happen and just promise you that it will ready up in time, but you've probably all had enough now Kubernetes and it's time to go outside. But now you've got a cluster that is ready to accept whatever you want to throw at it. You can obviously go and install things like Rancher and Longhorn, and you can follow my previous videos. Those scripts should still work for deploying these. And if you want to write an Ansible playbook and submit that, you can do that. Like I said, I wanted to keep this basically as pure to just deploying the cluster as possible. So congratulations if you stayed with me on that one, but hopefully it gave you a bit more of an understanding of what's going on under the hood in Kubernetes and RKE2. Like I said, this isn't perfect. I'm not professing that it is. I need your help to make this something awesome. A bit like TechnoTim has for K3S. It'd be great if we can get anywhere close to how good that is. Anyway, thanks for watching. If you've liked this video, you know what to do. Hit the subscribe and I'll see you on the next one. Take care, everybody.